The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, everyone. My name is Rory Mackay. I'm a systems engineer with GFI, and I'm here to speak about Exinda, and we're going to look over improving your network performance and quality of service with the Exinda specifically, and we'll take a look at, kind of how to overcome some challenges in today's workplace. So in the webinar specifically, we're going to begin by exploring the concept of quality of service, some of the details and what that entails, the definition as such, and we're going to also look at some of the different size Exindas for your models, how they would fit into your network, and some things to pay attention to when considering how to deploy an Exinda into your network and what to look for. We're also going to cover the optimizer. So I'm going to look specifically at some policies. We're going to demonstrate how you will implement that type of control and configure the Exinda. And we'll also look at some of the information and show you how easy it is to obtain what you want to know and to implement the policies or procedures and control going forward or on an ongoing basis. So we're first going to look at quality of service. And simply put, quality of service is essentially it's that end user experience that kind of determines the overall success of quality of service on your network. It's the idea that you want those applications on your network to perform flawlessly and seamlessly from end to end. And you want to have it very little impact to the end user as possible. The way you achieve that quality of service is simply by implementing a set of rules which will control how the bandwidth is utilized. It will ensure that certain applications on the network that are important to you, basically they'll obtain the bandwidth that they need, they'll perform as intended, and the ones that, the applications you don't want running on your network, conversely, will not get the bandwidth that you desire them to have, or they will get the bandwidth that you desire them to have, and they will ensure that they don't choke out or take away utilization of resources from others. So if we look at QoS, we want to ensure that we achieve quality experience for your customers' business critical applications. So how do we do that? At Exinda, we take what is often referred to as a multi-dimensional visibility and control approach. We like to provide you with the necessary information that you need to make those informed business decisions. So first, we ensure this quality of experience. As you can see here, there's a couple apps that we have as an example. And we do this by providing this visibility aspect. So the multidimensional visibility of your network, of the applications from not just the application standpoint, but will give you that insight as to the users, the hosts, the IPs, the network as a whole. We'll give you that information so you can see how it's working, so you can see trends, so you can see certain usage statistics, other metrics for both these sanctioned and unsanctioned apps. And the idea is, once you have that sort of visibility, you can begin to implement this method of control, this method of QoS, these rules. You can control the behavior of these applications. You can prioritize your sanctioned applications, and conversely, you can limit the unsanctioned applications as well. And this all comes into play because what's happening on the network today is there's a struggle for resources. There's been a shift in the overall trend. 10 years ago, you had a standard network. All the resources were kind of located on-prem. You had servers in relatively the same building. As we've kind of increased and time has gone on, We've moved servers off-site. So you've now had offices spanning multiple locations, or an office in one location where the servers are in another, and you're spanning miles or even states or countries, right? You're going international now. And we've further moved things now to the cloud. So whereas before you had this sort of reliable aspect, you've had this consistency with applications because you've had this hardline connection that you could control within your network. For the majority, it was initially just local. Now it's WAN. It's no longer local. It's in greater distances, and now more and more services are moving to the cloud. So what you have is an increase of what you would refer to as a latency-sensitive application. You have other aspects that affect the performance of these applications, and it makes it harder to guarantee that your end users or that your business can prosper effectively. So what essentially ends up happening is you get an inconsistent performance or inconsistent reliability for these critical applications. This is all kind of brought on by that sort of key aspect of this. But there's a few things that we also need to consider. Applications will fight for resources now even more so because of the BYOD. More and more people are bringing tablets and phones and laptops and all kinds of devices. They're bringing these into the workplace. And as long as you properly provide for them, you can control these applications that they're using or control these devices in a way so that they don't affect your critical business applications. So when I say critical business applications, what do I really mean by that? Well, you could say that a critical app is mainly an application that is sanctioned by the corporation and is important for business processes or users. But what does that really mean? Well, it's user-defined, it's corporation-defined. In a lot of cases, as you see here in this example, we have Word, Skype for Business, Salesforce, GoToMeeting. However, depending upon the business, these may not be as critical as, say, in a dorm room for a university. A dorm room for a university may have a very different set of critical applications. They may want YouTube streaming. They probably want Netflix. They would want to ensure that the students have the ability to browse Facebook. So it's highly subjective and user-dependent. And the key point here is you decide that critical application based on your end users and your business priorities, and you use the Exinda to help you do so. Conversely, we want to look at unsanctioned applications. Now, unsanctioned applications are simply those that are just not permitted for use. They may violate terms of use policies. They may be unimportant to use, unimportant to the business or the users in general. So, as you can see here, we have a few examples of WhatsApp, Facebook, YouTube, Twitter. Now, we could even go as far as to say that maybe these are unsanctioned applications to the business for certain groups or certain departments. Because while unsanctioned applications for one department may be these, Facebook, Twitter, YouTube, however, you may have that very same group sanctioned for marketing. Because marketing may have a totally different set of rules, because marketing needs Facebook, they need Twitter, they need to stay connected, they need to be actively engaged and involved in the community. So the Exinda will not only allow you to identify an unsanctioned applications, it can also identify and allow you to create these unsanctioned applications on a user basis or a group basis. So this is a very interesting statistic. And what the end result is, we've identified a need. And the need is that I talked about BYOD, and people bringing multiple devices and creating this sort of struggle for resources. And the numbers is the average company has around 1,200 applications running in their network, of which 98% are unsanctioned. And when I say unsanctioned, it's, going back to the previous slide, I talked about the fact that most of these apps could be unsanctioned, but marketing may need Facebook, social media. There's also something referred to often as a shadow IT application. Some of you may be aware or have heard this term before. And this is simply an application that the business uses, that the business doesn't recognize or isn't even aware of, but the end users are using it to somehow increase the performance of their work day or increase their efficiency. They may start to utilize a certain application because it adds benefit to the end result or the performance of that day. Now you can basically start to see this sort of trend happening with this more usage, and the Exinda will also be able to recognize those increases in usage. It'll recognize those patterns or these emerging applications. It'll be able, essentially you can identify this shadow IT stuff, or you can identify the ones that are being used more and need to be kind of squished out or choked. Now conversely, this all relates to the fact that 2% of the applications are sanctioned. So IT has a very difficult job. The IT manager has to ensure that the network performs seamlessly, that this quality of service aspect is there, and that users aren't waiting for load times. Now, I spoke about the multidimensional visibility and control aspect earlier. Part of how we achieve this is by utilizing various layers of the network. So I mentioned the fact that you can get the insight into the IPs, the hosts, the even users and groups for Active Directory, and the application level. So this is an application level perspective. And what we have here is, this is the landing page, which you will see in a moment. And this is the bandwidth utilization, part of the visibility that we talked about. So you can see here there's a top 10 inbound application groups and top 10 outbound application groups. And it's simply a list of common applications that are grouped or have similar sort of tasks and characteristics that are commonly grouped. So web is the very first one, and web is simply anything that uses a web browser, so HTTP and HTTPS. We also have mail services, file services, P2P. We've also continued to, or even created, our own Exinda group. So this is a highly customizable sort of aspect of the Exinda, which you're really going to want to take note of and utilize, because you can change your groups around, you can create custom applications, and you can also create your own. So you don't have to use web. You could, if you wanted to, you could move web services into the Exinda group. Now this is all a snapshot of the first page, which is very high level, and it gives you this insight, which also provides the ability to drill down. And by drilling down, what you can do is you can see that information, you can gain that insight, and you can prioritize those critical applications. Because Skype for Business, GoToMeeting, Office 365, they're all going to use this sort of web traffic group. So if you see them and you can classify them, you can begin to control them. You could control that entire group, or you could control them individually. It's all about identifying the need for these to prioritize these critical applications. And by doing so, you can identify those mission critical apps, you can ensure that they're prioritized, and you can ensure that they perform reliably and consistently. Now, I also talked about controlling the unsanctioned apps. And the way to kind of look at it is that unsanctioned apps, when you have all the applications in, looking at your bandwidth, for example, you have a gigabit of bandwidth coming into the site. And all of the applications are basically like newborn birds in a nest. And they're all chirping and trying to gobble up as much bandwidth as possible. And sometimes they get more than they need, sometimes they don't. YouTube is a perfect example, or streaming. What they will do is, if they're given the chance, they will stream at high definition. And high definition takes a lot of bandwidth. So something you can do is you can control YouTube. You could ensure that YouTube never streams anything higher than standard definition, which is 400K. So when you start to implement those types of policies and that types of control, that has an effect on the overall bandwidth usage, which frees up that much more resources for your important things. So as I mentioned, all of those applications are competing. Everything that is in the bird's nest is looking to get bandwidth. And as you can see here, this is just a reiteration of the application group. So you look at the web services, and as you can see, we have web is taking up the majority of the pie, and then database is, a close second, followed by your mail services, which is no surprise. Anyone who maintains a mail server would understand that. So if you look at the top inbound application groups, you can start to see these patterns and these trends, and you can also look at them from a performance perspective as well. So this is not just the usage, this is not just the overall bandwidth, we're also looking at the applications from a performance standpoint. How are they acting, and what is their behavior on your network? So the QoS is also, we're taking a look at the average amount of the total amount of packets, the data involved, the throughput. We look at the flows, round trip time. We look at if there's any server delays, network delays, transaction delays, and then we also look at the overall efficiency. So as you can see here, web traffic has a 99.95% efficiency, which is pretty good. That's pretty darn good. And what that means is 99.95% of the time this application is performing according to it's reliable. And 0.05% of the time there's some packet retransmissions. So if you saw a very low number here, that might be a bit concerning. You might need to take a look at certain parts of your network and infrastructure. You might need to contact your ISP and say that their router's dropping packets. It's a lot more information to give you this multi-dimensional visibility aspect. So you can not only just, control bandwidth at this point. You're now seeing these areas of the network and gaining this insight and this crystal clear method of controlling it. Another thing I wanted to talk about here is I mentioned that we organize the applications into groups. So we don't just stop there. We also have the ability to look at the top applications. So we monitor all the applications coming in up to 1,000, and we'll look at the top applications. So as you can see here, HTTP is number 1. So that's the part of the web traffic, and obviously it makes up the large portion of that web traffic. However, you can see HTTPS, the secure side of web traffic, is very minimal. And second is MySQL. So if I looked at that, I can quickly ascertain that my users are using a lot of web traffic, but it doesn't appear that they're using the secure stuff. So perhaps they're using something else that I don't want them to know about. If I wanted to, I could click on that HTTP. I could see the top applications themselves, or the users that are using this traffic. And I can drill down further and gain further information or insight. If I clicked on the user themselves, I could also see what they're using. So what does this all translate to? What is the sort of the main aspect or the main idea? And the main idea is that the customers or your needs are very, very simple. You need to ensure this quality of experience or quality of service aspect for your users. You want your network to perform seamlessly. You want it to perform or work as intended. And in order to do so, you need these applications that your business relies on. The Salesforce, the YouTube if that's a priority, Slack, or perhaps Outlook, or Office 365. You need these applications to work as intended, as though they were on-prem, because they're not on-prem. They're in the cloud a lot of times. So having a look at the optimizer, I mentioned that we control traffic. We provide or guarantee this quality of service aspect. We had a look at some of the visibility issues, some of the visibility angles. Now we're going to take a look at the optimizer, and we're going to explore how we implement those controls, how we make those informed decisions, and how we implement those rules. So if you look at the optimizer, it's a very simple concept. It's basically a circuit. So as you see at the top here, we have circuit 10. And the circuit is just a concept of a bridge. And it's basically, it could be one bridge or it could be all bridges on the appliance. And a bridge is just a WAN port and a LAN port. One receives traffic from one direction, and then it sends it out the opposite port in the other direction, and vice versa. So as you can see in this example, we have the circuit is, the bridge is 20 megs in, which is 20.448 if you want to get precise, and 10 megs out, so 10.24. If you wanted to, you could configure this as 20.48 in and 20.48 out. The device itself is full duplex, so it'll work 20 in both directions. Now, within the circuit is where you start to nest your virtual circuits. And your virtual circuits are typically divided based on a network. It's what we refer to as a network object. So a network object could be an individual IP address of a computer or a host. It could also be a range of IPs. So it could be an entire network, or it could be just a list. It could be a set of users that you wanted to create this virtual circuit for. Now, in this example, the virtual circuit is for all traffic, all IPs, all hosts on this internet connection. And within there, we have a list of rules. And for anyone who's ever worked with a router or worked with a firewall, it's very similar to an access list in the sense that you stay pretty specific at the top, and as you move down, you get general. So as you see at the bottom, we have a policy for all traffic. And then at the top, we have some P2P, Netflix, gaming, recreational, software updates, what have you. Now here, this is where the optimizer becomes quite dynamic. And what we do is we employ this concept of guaranteed bandwidth. So I mentioned earlier that you want to guarantee that your critical applications perform flawlessly. So we're going to essentially guarantee, and I'll use GoToMeeting. So the policy here is to guarantee 10% of the bandwidth up to 100%. Likewise, Salesforce and Office 365 is guaranteed high, 10% up to 100%. Now, if you look at HTTP, we've guaranteed 8% up to 100. And what this simply means is the guaranteed amount is the percentage of the bandwidth that you want to ensure that this application will get all the time. So all the time, Office 365 and Salesforce is guaranteed 10%. GoToMeeting is guaranteed 10%. HTTP traffic is guaranteed 8%. Now this other value here, as you can see for software updates, it's 3% to 50. So that second number is what is referred to as burst. And the burst amount is quite simply anything that's left over. So after all of the guaranteed amounts are satisfied, if there's any bandwidth that's left over, this is where the additional quality of service aspect comes into play, because anything that's left over can be divvied up or divided amongst the policies as you see fit. Now it's based on a priority. So as you can see here, anything with a lower priority is going to most certainly be guaranteed the majority of the burst, and anything with a higher priority is obviously most likely hardly ever going to get the extra burst. And it just makes sense because you want to ensure that extra element of control or that extra element of success for these applications. Now here we have a P2P choke. We also have a Netflix choke and a gaming choke. And the reason why we implement the choke is because it's considered best practice. And this is quite often because we found that sometimes particularly in P2P, the application, if you're just dropping or discarding the packets, which we do allow you to do, it is a configurable option. If you're just dropping the packets, some P2P or torrent applications will recognize that fact and they'll alter their behavior, switch ports, and then sometimes bypass the application definition. So it's not a desired sort of intent, or it's not desired at all. So what we do is you implement the choke. I usually suggest 1 kilobit to maybe 2 kilobits, and then the application will open up the session and it'll maintain the flow. It'll just be very, very slow forever, right? So yes, they have a connection, but they're not actually accomplishing anything. So how this really all translates is proper bandwidth management, proper QoS. And in the previous example, just to review, what we achieved by having that small set of rules was protecting the critical applications. We protected Office 365, GoToMeeting, and Salesforce by ensuring that it was given the bandwidth that it needed at all times. It was guaranteed. We also implemented control over the video traffic, and we contained that video traffic. We implemented that restriction so that it couldn't hog or gobble up all the extra bandwidth. It couldn't, obtain that 4K streaming definition, which would bring a network to its knees in some cases. We also implemented the control over the social, gaming, and media traffic, which in this example above was not desired. We implemented peer-to-peer and torrent traffics policies to stay compliant, fair usage, what have you. And we also essentially achieved this aspect of QoS. We've provided this predictable and consistent application performance. And that's basically the goal. That's what we want to ensure. We want to decrease the aspect of this risk. Now here we have the Exinda appliance family. Some of these devices, as you see, we have the 3062 and the 4062. Now these are for small and medium offices. They scale, they have failover capabilities, they have copper. The 4062, once you get into that, you can get into fiber. And they scale all the way up to our largest system, which is a 12K or 12063. Now these systems, when you look at them, it's dependent upon, there we go, hit my mouse. It's dependent upon a few factors. So if you look at the Exinda hardware portfolio, the 3062 is essentially you want to look at bandwidth. And you want to look at the characteristics of how much bandwidth is coming into the building itself. So the 3062 starts at 150 for diagnostics and shaping. Then we go up to 1 gig, and then the 863 is 5, and so on, up to 15 gigs with the 12063 or 12K. So the other thing that you're able to do, I keep wanting to scroll down here, I apologize, is we support a variety of different functions as well. We support a software deployment, so in a virtual instance, and we also support high availability. So you can cluster 2 Exindas together to provide for that failover or also increase the performance. As you see here, another thing you want to look at when you have bandwidth consideration is the amount of users you're supporting, and you want to look at the connections. Sometimes you may have a lot of users opening a lot of sessions. If they open quite a few different windows and what have you as part of their browsing to accomplish the task, you want to look at certain aspects like that. So you take this all into consideration when you're sizing the appliance, but the main thing is you start with the bandwidth and then you fine tune from there. You put it in the network and you run it and you get an idea or that visibility of those applications that are important to you. If, some cases you're aware of those applications, you have an idea. Some cases you may not be aware certain applications are even running. We had a case where we implemented the Exinda. They had it running for 2 weeks, and they noticed over 12% of their bandwidth was going to VPN. They had no idea. They investigated, they found the cause, and they resolved the issue. Now they have a policy and to choke out VPN traffic. So this is just sort of part of the visibility that you will glean, you will be able to see by using the Exinda and having it in your network. Another thing I wanted to talk about is the devices also. I mentioned the failover capabilities of the bridge. And again, the bridge is just the concept of a WAN port and a LAN port. Now they also support expandability, so you can put multiple cards in some of the higher end appliances. And they also offer redundancy. So redundancy doesn't just kick in from a high availability standpoint where you can cluster. It also gets into, once you start at the 863 and the 10K and the 12K, you can look at, we have power redundancy and multiple hard drives in a RAID fashion. So we can ensure that your data is protected and secured, and it's also you're not going to lose it anytime soon. Now I'm just going to take a moment and we're going to I'm going to show you the demo. So the demo is, you can access this at any time by going to demo.exinda.com. And I'll just show you here. So demo.exinda.com, and then you would select to spin up an instance of the demo, and then it will provide you with a link, which you click on, and it'll take you to the login page, and you just provide the credentials. And I encourage you to explore the system and see exactly what it can do for you. A typical deployment of an Exinda, as you see in this case here, is a hardware instance. So the demo Exinda is behind the default gateway, and it basically will inspect every single packet that comes through the gateway. So this could be the firewall or the router. It'll go through, we prefer to be behind the firewall, go through the Exinda and then out to the users on the other side after it comes through the WAN. We also offer multi-site deployments, so you can see in the case there's 2 Exindas, you would have, say for example, you had a head office where there was another Exinda, and you could, control the traffic, from site to site or on a site-to-site basis as well. So in this case, we have a server behind an Exinda at the other side of the WAN. So I'm just going to take a moment. I'm going to log into the system, and I've already forgot my password, of course. 1946. So logging into the Exinda, this is the page that I have spoken about earlier. I'll probably have to accept Flash. Now, one of the things that we're changing is we're moving to HTML5, if some of you are curious. So here you may recognize this page. As you can see, I spoke about this before. This is part of the multi-dimensional visibility aspect. We have our top 10 inbound application groups, our top 10 outbound application groups, and we also have different time ranges. So you can see this is just a snapshot for today. So you can have a look at the overall network utilization, you can take a look at the hosts, And then we also have the link utilization. We also identify peak periods of usage, the top IPs involved in the conversation, and the top applications, and how much data they were using at the time. These are signified by green dots. I also mentioned the fact that we could drill down, so we could get that visibility. If I had an issue with P2P on my network, I can see 11 hosts are using this right now. So I'll click on it. When I click on the P2P, I now have an idea that in the current day, this is the application that's running in P2P is BitTorrent. If I wanted to, I could go even further. And I can see the hosts. So I can see one host appears to be receiving BitTorrent traffic, and all these other hosts are sending it. If I wanted to, I could even go further, and I can click on the host. And I can see the applications that the host is using. So it's very, very insightful. I can see exactly what they're doing on the network. And I can, rest assured, see that they're not doing something, or they are doing something that they shouldn't be doing, with probably using a proxy, because it looks like a list of random ports that they're trying to go through. These are not typically common ports. So I'm going to go back to the dashboard. That's just one example of how you can identify this traffic and these traffic patterns. Another way you can identify is looking at the application specifically. So if I look at the applications, and this is all historical data, if I wanted to, I could look up 60 minutes, 24 hours, 7 days, all the way up to 2 years. So this gives me a list of all the applications that are running in my network. I can look at the top applications that are on the inbound. I can also look at what's going out, and I can identify all my usage. If I wanted to, I could even expand the table to 1,000 entries, and I could find something. So if I wanted to say, let's see, BitTorrent. Oh, BitTorrent's up there. Let's look at Skype. Oh, that's there too. I can't think of an application. Twitter? Oh. Well, I can't think of an application that comes to mind, but as you can see, if it's been there, if it's been through the Exinda, it has it. So as you see, we'll store up to 1,000 entries in this table for usage statistics. I just couldn't think of one. I don't know why I couldn't think of TACAX or SIFs or any of those that weren't in the top 10. My mind escapes me right now. So anyways, as you see, it's quite handy when identifying these patterns or traffic usage statistics. Now the thing is you don't always have to. I mentioned the fact that if there's an increase in utilization or a pattern that the Exinda will notice, it'll see this trend. Say for example, WhatsApp. If WhatsApp it just exploded overnight, and more users started using it on the network, and they started using it because they were like, oh, shoot, I can send encrypted traffic and text messages all I want. So you would see it in here under the recommendation engine. It would tell you, right now this is telling me that I have traffic in my network that is being unclassified, so I'd like to classify it. However, if there was an increase in WhatsApp, it would say, Exinda recommends that we've identified WhatsApp has occurred in the top applications, right, over the past 24 hours or 2 weeks. We recommend you do something about it. So even if you don't notice something, the Exinda typically will. And how do we do so? So we do so from a configuration perspective. And I'm going to show you exactly how easy. So this is a pre-built configuration that the Exinda has. Now I'm going to show you how easy it is to configure the Exinda. So this is a pre-built configuration that I have from a previous configuration. I'm just going to implement that. Oh, hold on. Whoops. I forgot to delete the old one. Now that should take. There. Okay. So the reason why I got that red message was because some of the policies are already in the Exinda in the system. So what it does is if you create a new policy, it will keep it and store it. So if you remove it from the configuration, it still has the policy in the system. So it's always there. So some of these I already had in there. So as you can see, guaranteed all. Because I was trying to recreate it again, it wasn't. It was just telling me it already exists, so you don't have to add it. So as you can see, I just quickly added my whole configuration by copying and pasting. And it's very nice because if you have configurations, they're easily portable. Now, if you wanted to, you can also, I'm just going to remove this policy for Office 365. If you wanted to, you could simply just take one out with the click of a button from the GUI interface. Some people, you prefer to use the GUI, and that's fine too. So I spoke about the fact that, as you can see here, we have a circuit 10, which defines the traffic. We also have a virtual circuit 20. And the circuit 10 is just the 20 in and the 10 out. The virtual circuit is actually defined by the network object. So in this case, we've got it, which is all. However, if I wanted to, I can use a specific user and group. And this is a user and group called staff. And that's just simply because we have something called Active Directory integration. And Active Directory integration will pool the event log on the server, and then it'll just resolve the IPs. So it supports users, and it supports groups, and it supports nested groups. So in this case, I have a group staff. If I wanted this virtual circuit to apply to staff, I could do so. Or if I wanted to, and apply all these rules, but slightly different, I can clone this virtual circuit, right? So it's, instead of calling it copy of internet, I'm going to call it staff. I'm going to get really interesting. And I'm going to make this for staff. Now, because it shares the similar characteristics of an access list, and the other virtual circuit is for all, I'm going to put this above that, so I'm going to give it a number of 5. So now I have a virtual circuit completely separate from the other one for staff specifically, or it could be any Active Directory group. For example, I mentioned that earlier you could set up your network based on network objects, and they could be IP-based. It could be, in this case, we've got a branch office network object, and it's just a list of hosts. So these individual IPs, perhaps they're a list of C-level executives that I want to control separately, and I want to give, or this could be a list of the marketing IPs. Or if I wanted to, I could use an entire network, in this case, which is LAN. So going back to the optimizer, if I wanted to implement policy on any of those specific groups, just with the click of a button or a simple cloning, I could do so. So now I'm going to go back to that, and I'll choose branch office, for example. So now any IP that fits branch office will come in, and it'll fit this virtual circuit, and it'll be shaped accordingly. So say, for example, as I mentioned earlier, this could be the marketing group if I wanted to create a marketing policy for Facebook and social media. Since we already have we'll use recreational because I think social media is in recreational. So I'm going to add recreational to this policy because marketing is in there. So I'll give it a 15. Oh, actually it already is in there. Well, since it's already there, let's just say I wanted to change it. So instead of choking it out, I want to give it a limit low. I could have selected the different policy and put it in, or I can actually edit this one. So I can edit this one, and I could increase the amounts, and I could give it a 20% guaranteed, and I could actually make it burst up to 50%. And if I wanted to, I could give it a higher priority so that it gets the burst that it needs. So this is all this aspect of control. I select the recreational traffic. If I wanted to, and say, for example, this policy, or these people, these group of users were in the other virtual circuit, I could simply just select it from here. So you can control this aspect, and you can also decide what to do. You can optimize it, which is guaranteeing the amount. You can discard it. You can ignore it. You can return an HTML response. You could say, please don't go here. Or you could even redirect it completely. So there's a lot of options and a lot of personal control that you can apply. And I am about 5 minutes over, so I'm going to cut it a little bit short. But that's a good overview of the system. And I think we're just going to go ahead and accept some questions now, if there are any. Helena, did you want to direct the questions?
Hi, Rory. Hi, everybody. There hasn't been really any questions connected to the webinar, but just the one that came through a couple of times, whether the webinar has been recorded. Yes, the session is being recorded right now. We will be sending a follow-up email 24 hours after this is finished. But other than that, no questions so far. So I encourage all the attendees, if they have any questions, to type them into the chat window, please. All right, here we go. Is this in addition to Mail Essentials or a completely different product?
This is a different product, a separate appliance entirely. Yes.
If a customer connects two separate IP ISPs, can one traffic shaper control those links?
Yes. So in that instance, what you would do is, let me see if I can give you an example here. So in this case, on the back of this Exinda, you can see there's Ethernet 0, 1, 2, 3. So we have multiple Ethernet ports. Some Exindas, as you go higher, the Exindas will have more and more bridges. So essentially, you would just connect each individual ISP to an individual bridge. So it would be the WAN in and then the LAN out to the switch. So actually, let me take that further. So where you get more precise is in this the circuit here. Let me minimize this window. So the circuit here, once you've got two bridges, is you would see the bridges show up, and you could configure them separately. So if I wanted this for bridge 2, I would just configure it for bridge 2, and then I would create a separate circuit for bridge 3, 4, 10, what have you.
Thank you, Rory. Another question, will Exinda eventually use HTML5 or other than Flash?
Yes. So it is our intent to release, I believe it's 6 version. So we're currently on version 7.4.4, update 2. We're proceeding to release version 7.4.5 within this quarter. And I believe the next release, we're targeting HTML5, provided everything is transitioned smoothly. And we will be completely out of Flash. So It's a good question.
If I can block a website and applications through my firewall, how does Exinda help additionally?
Well, let me give you an example. So the firewall will block the application, but it doesn't necessarily control it, which in some cases that's a very nice situation. It's a binary approach, but it helps, right? However, in the case that I mentioned earlier where the customer installed us in their network and they had, the 12% of VPN traffic, this was a school, and what was happening was the students were using their cell phones to create a VPN tunnel. So they were creating this VPN tunnel through their internet service provider. And then once they got to the school, they were migrating to the access point at the school. So they were now on the school's wireless. And because the tunnel was already open, the firewall was like, oh, okay, sure, yeah, go ahead. And the content provider, well, it was encrypted traffic, so the content provider had no idea. And this was about 12% of their bandwidth the students were doing on a day-to-day basis. And they had free reign over the internet, and they had no idea. Imagine the implications of that. So that's just one way that the Exinda can help. We're not a security solution, but we complement a security solution and a content management solution very, very well. We work very well in tandem with those.
Thank you, Rory. Another question. Is there a way to export user-created applications in order to import if, say, we're installing Exinda?
I'm sorry, can you repeat that?
Is there a way to export user-created applications in order to import if, say, we're installing Exinda?
To import user-defined applications from like other sources? Well, let me just sort of give you an idea. The Exinda itself has over 2,500 predefined applications, and let me just show you quickly here. So these predefined applications are based on a variety of different identification techniques. So we work on virtually every layer of the Aussie model. So if you take a look, Acronis could be, it's simply a TCP port and a UDP port definition. And this is something that kind of sets us above a lot of our competitors, is because of the depth of our definitions and the amount of them. We don't just support a few. I mean, we have ActiveSync, which is a completely, it's a layer 7 definition for ActiveSync. So we're actually looking at the payload, and we're looking at, the content. We're analyzing the behavior of it. So we employ behavioral algorithms or utilize other heuristics to identify this traffic. In some cases, it's simply, if we go down to Apple updates here, it's, Apple updates, which is based on the host and a simple URL. So chances are we have the definition, but if, say, for example, Apple goes ahead and they change their definition, they start going, to a new site. Well, guess what? You can edit that quickly. I'll just click on the edit button, and it'll take me to the edit page. Hold on. Oh, demo's being a little slow. So now for the Apple updates, let's say, for example, they added an HTTPS definition. So I'll go to SSL. I'll select the common name. And I'll just say ioupdate.com. Apply the changes. And now I've got a definition for the Apple updates in addition, because I saw something was getting through. And the way you can see if stuff's getting through is by looking at the real-time monitor. which is something that I wanted to touch on, but I didn't really get the chance to. So I can see now that traffic is running through the appliance, and this is a snapshot up to 60 seconds of data. Anything greater than that is obviously historical, and you would go into the historical reports. But you can check out all of the stuff that's happening on the machine. You can see individual users as they are using the bandwidth on the system. If I wanted to, because I have Active Directory installed, I can actually see that Gabriel is talking to Valeria, and they're transferring some kind of a large file at 24.687 Mbps. So this gets very handy for helping troubleshoot real-time sort of issues, because you can also look at things like host health. So if there was perhaps a very large attack that was coming through the system, I mentioned that we weren't a security, we're not a security appliance, but this is where we can help. Because you could see, if there was a massive SYN flood, you could see a massive amount of aborted, ignored, and refused connections, and you could identify some of the IPs that are being targeted. So it'll help you or aid you in that process of identifying those issues. Okay.
Hillary, with another question. If a school district has 10 or 20 schools running through a central office to the internet, can Exinda apply the same policies to the feeder circuits coming into the central side? For example, control YouTube from traversing the feed links?
Yes. So this is where we do some of our best work. Because what this allows you to do, so you can do this a variety of ways, but a lot of, I mentioned earlier that you want to divide your network up into virtual circuits. So I would imagine that your sites would be separated by probably VLAN or segment ID, network ID. So what you would do is you would create a separate virtual circuit based on, the individual networks for the different schools, right? And then you would, you could also, something that I didn't cover, these are some very good questions actually. If I wanted to, I could, say this virtual circuit, instead of getting 100% of the bandwidth, I could say it gets 50% in, or I could say it gets 20%, right? Or I could even specify a specific KB amount, and I could say this is going to get 2 megs. So now what I've got is, let's imagine that this is not the staff Active Directory, that it's actually a school based on a network ID. I could say, now this school is going to get 2 megs, all traffic, and then each policy is going to govern that traffic as I've defined these rules. And I could separate these rules, I could create new policies, I could remove the ones in place. It's fully customizable.
Thank you, Rory. Can Exinda detect proxy bypass applications such as UltraServe?
Yeah, so when you're dealing with things like proxies and whatnot, is we have a list that we maintain, and then what you would do, I have to always look for it. Using network. Yeah. Nope, that's not it. I always have to look for it to search it. So you basically have to just enable an anonymous proxy option in the system. NetFlow, scheduled license storage, alerts, and monitoring. No. The short answer is yes. So we'll detect the proxies. You enable the checkbox, and it will essentially enable anonymous proxy. So we have a list that we maintain and update. So then you can apply control or restriction based on that as well.
Thank you. Another question, if you have multiple bridges, does the dashboard reflect aggregate traffic of all the bridges?
Oh, yes. So so the dashboard here, yes. So this would just be, yeah, this is a snapshot of the entire network. If you wanted to get into specifics as to multiple bridges, you can look at a variety of different sort of aspects. So you can look at the virtual circuit monitor, which I don't have any data available because I changed it. So let's go 30 days. No, yeah, because I was messing with the demo environment. But what you would see is a virtual circuit breakdown, and it would tell you essentially how the data is being utilized on a virtual circuit basis, which would also tell you exactly what the individual subnets were using. If you wanted to, you could also look at the subnet usage as well. So in this case, we have a variety of different subnets configured, and if I wanted to, I could click on LAN and see exactly what those usages are. So there's the aggregate view on the dashboard, but there's also the more specific views when you get into the historical analysis of these actual segments in our monitoring, right? So I mean, we even have a host section where you can see the IPs. We have the users, so this is where your Active Directory comes into play. Here's the control aspect. So the control aspect will show you the different circuits and their utilization on an individual basis. So we can see that the default circuit, here's the amount of usage, and then here's that internet circuit which we have configured, and here's the overall usage and utilization as such. Okay.
Thank you. That's all for questions for this moment. So I suggest we give one another minute for any further questions.
Under applications? Possibly. Ah, there it is. That's right. So yeah, so you just enable it. I can never remember where it is. There's a couple things. It's because the system has so many settings. It's hard to navigate, and I'm kind of a CLI guy anyway. So, but yeah, so you would just apply the changes, and as you can see, here's the URL. So we get the list that's maintained, and it'll basically update it, just renumerate it, and it'll refresh the list.
One more question, Rory. You mentioned adding Exinda itself as a monitored application. What does the overhead look like for Exinda itself?
The overhead. From a like power utilization, or I mean, sorry, don't really understand the question.
Kyle, can you please specify your question? Network traffic specifically.
Well, the Exinda doesn't make any routing decisions. It's a transparent bridge, basically a layer 2 transparent bridge. So we just basically inspect the traffic as it goes through. We inspect every packet, right? As I mentioned, in some cases, we actually look at the payload. And then we basically make a decision on how to control that traffic. So whatever the Exinda is given or is sent to it, the Exinda has no control over, but what's going to pass through it will control, right? Well, the purpose is to control the traffic as it flows through the network. So you want to ensure that your applications get the bandwidth they need. As I mentioned earlier, a common problem with everything moving off-site, with all the devices, BYOD, everything competing for bandwidth, streaming, taking HD video. You can put appropriate control mechanisms in place to ensure the quality of service or experience is, quite adequate for the users. You can implement fair usage policies. Some places have, they need to guarantee each user on an individual user basis gets 1 megabit of bandwidth at all times. Well, you can do so with the Exinda. You can actually control the traffic on a per user basis. So when you're looking at the need of the network, it serves a wide variety of purpose. The main thing is to, ensure that quality of experience or quality of service aspect. So why do you, as an inbound application group? So again, because when you have a whole bunch of applications competing for bandwidth, right? By controlling the bandwidth, you can ensure that the user will get the amount of bandwidth from a reliability standpoint, right? So they're going to get the amount of resources that they need.
Thank you, Rory. I think we've run over the 1 hour. I trust we can finish the webinar right now. Thanks very much for providing the thorough webinar. The introduction to the product was really well done. As I mentioned, we will be sending a follow-up email with a recorded version of this webinar, so you can use it for future. And thank you for attending today's webinar.
Thank you, everybody. And as I mentioned, please feel free to use the demo site, demo.exinda.com, and play around with it, try configuring and looking at some of the report data. Thank you.